Just want to introduce you all to our guests. So Eric Smith is a distinguished engineer who works for Dell Integrated Products and Solutions CTIO team. He's currently focused on next-gen storage networks and the creation of centralized storage services for NVMe OF. Previously, he led the engineering and advanced development for Dell's Connectrix business unit and was responsible for working with Dell's partners to address architectural problems and collaborate on new features. Curtis Ballard, he's a distinguished technologist with HPE in the HPE storage unit. He works on emerging storage technologies and industry engagement. He's on the NVMe Express Board of Directors, the SNIA Technical Council, and is the Vice Chair of Insight's T10 SCSI Storage Interfaces Technical Committee. Curtis has worked on storage products across the industry, including host drivers, ASICs, standalone drivers, and complex storage systems. So today, these are the two that are going to answer both some of my questions as well as some of your questions about how NVMe impacts the enterprise space. So definitely want you guys to be thinking about what questions you may have for them, but I'm going to kick it off here with a couple of questions of my own. So Eric, let's start with you. Can you tell us about centralized discovery, its importance, and what problems that it solves?
Sure. Thanks for the question. For me, I come from a fiber channel background. So when I think of enterprise, I think of storage connectivity. And one of the big attributes of storage connectivity in an enterprise is the ability for hosts to automatically discover storage without having to go to every endpoint and configure it explicitly to point at specific storage volumes. So when I think of storage connectivity in the enterprise, it's really like that fiber channel model. So as we were thinking about NVMe over fabrics and how we could bring it to the enterprise, one of the things we noticed that was missing right off the bat was those storage services. They didn't exist. So configuring NVMe over fabrics in a sort of at that time was much more like configuring iSCSI. You go to every end device, point it at the specific storage volumes, and you get to repeat that on every host. And it wasn't a great user experience. We heard that from our customers pretty clearly. So we said, well, what can we do to add centralized discovery or a fiber channel like user experience to NVMe over fabrics? And it just so happens a bunch of other people at the same time were thinking along the same lines. And so we started working with HPE and others in the FMDs group as part of NVMe Express, and started coming up with a way that maybe would provide a fiber channel like user experience to customers who wanted to use NVMe over fabrics because it definitely has advantages over fiber channel, and so we wanted to enable that end users to use it in the best way that they saw fit. So that's pretty much what I think about centralized discovery.
Yeah. Curtis, did you have anything to add to that? And one thing you may also talk about is, Eric mentioned FMDS. Maybe just share a little bit about what that is with the audience as well.
Sure. Okay. Thanks, Nick. FMDS is one of those acronyms that those of us in the industry love to become so familiar with that we assume the rest of the world is too. Within the NVMe Express organization, there are far more things that people want to do than we can possibly accomplish in the time we've got available. So we've created a bunch of different task groups that are focused on specific technology spaces. In some of the meetings here, you've heard about ZNS, and the ZNS folks in NVMe Express have their own task group that focuses on ZNS-specific efforts. So the fancy acronym FMDS stands for Fabrics and Multi-Domain Subsystems. Fabrics, hopefully, is a term most of you will understand. Multi-domain subsystems, we're down into the weeds of NVMe Express, trying to keep the knowledge to the elite few, I think. But basically, that's the group that deals with larger, more complex systems than standalone SSDs. And when you get into storage arrays like Eric's company, my company, and others make, a lot of the things that are very specific to storage arrays are worked in FMDS. And I think Eric did a good job of answering the question from the Fabrics perspective. I'd like to think about from a little bit different perspective as well. The world has changed a lot in the last few years, and one of the things that is really different than when some of the Fibre Channel and SCSI implementations were done is that there's a lot more focus on virtualization, composability, extracting the operating environment from what the customer sees. So from the perspective of a emulated environment, a lower level, a software assisted design acting as if it were a bare metal server or a low level server. Some of the things like the centralized discoveries is really important for being able to provide services in the fabric that allow the management software that makes your cloud virtual machines look like a bare metal server and be really fast. When you're booting up a virtualized instance that is pulling its storage from somewhere remote out in the fabric, it needs to be able to very rapidly locate all of the fabric services that it uses and compose the virtualized instance that you see. So there's a lot of complexity that gets built into the specs, and reading the specs, it might look fairly complex, but the end goal is to make it simple to the user.
Thanks a lot, Curtis. Definitely appreciate it. And just a reminder, I want to encourage you guys, if you have any questions, feel free to step up to the microphone and we will take them. But for now, Curtis, I'm going to go back to you. What are some examples of real-world use cases for NVMe over Fabrics from your company's perspective?
Okay. Real-world use cases for NVMe over Fabrics. I think I just mentioned one of the real-world use cases when you're dealing with a completely composable system, having the ability to have that very high-performance storage that has performance very similar to direct attached storage and latency characteristics very similar to DAS storage is really important. And there's a lot of people that may be using fabrics attached to NVMe storage that, in their view, will be seeing it as native PCIe attached, and they don't need to know that it's a fabrics implementation.
Yeah.
I think there are three use cases from Dell's perspective. The one that's easiest to talk about is using NVMe TCP as a replacement for iSCSI. Early performance testing that we've done has sort of shown that NVMe TCP outperforms iSCSI in almost every way. And so it's almost a no-brainer. It's better CPU utilization characteristics, better latency, more IOPS, just any way you want to slice it or dice it. So that's one. The other one that makes a lot of sense for us is as an alternative to the use of Fibre Channel. I have spent my entire career, minus the last 2 or 3 years, working on Fibre Channel. I started with it at 1 gig, and with directors on McData directors, ED1032s, and have stayed with it throughout my entire career. Worked on FCOE for a little bit, and so I know the value of Fibre Channel and what it does really well. But as we started looking at the futures for Fibre Channel and where it meets Ethernet, there's going to be a crossover where Ethernet just makes a lot more sense from a physical transport point of view, and a number of different ways you want to slice it and dice it: cost, performance, and so the work that we did with Centralized Discovery was to again make NVMe over Fabric, specifically NVMe over TCP, an alternative to Fibre Channel. Although there are definitely use cases where you'll still use Fibre Channel for a while. So it's an iSCSI replacement. It's a Fibre Channel alternative, but it's also really good for as Curtis was mentioning, composability. And the one that I like to think about is edge. When we're thinking about getting block storage access all the way out to the edge, it's not going to be Fibre Channel. It's not, it's probably not going to be Rocky. So if you need that block access all the way out to the edge, NVMe TCP just makes a ton of sense because you don't have to do specialized network configuration. You don't need specialized network adapters. So that's why we're excited about NVMe TCP. And the other one, just the last one, is software-defined storage. As you're thinking about building out software-defined storage implementations, again, looking at the other protocols, NVMe over Fabric starts to make a lot of sense. And you could argue whether RDMA or TCP is better there, but I think there's use cases for both.
Yeah, if I might, Nick, there's one other use case that we often overlook that is actually one of the cases I've seen deployed quite a bit already, and that is that NVMe over Fabrics is being used as a higher performance, more latency sensitive replacement for direct attached storage expansion for some of the places where we used to use SAS JBODs. Instead of using SAS JBODs, there are a number of companies in the industry that are now using NVMe over Fabrics implementations. A lot of those are using the RDMA RoCE v2 implementation, which is not suitable for long-term applications. Like Eric was saying, it's hard to run over an extremely wide area, but when you're doing a SAS replacement close to the server, there's a number of companies that have had good success using NVMe over Fabrics with the RDMA attachment straight to the server for direct attached storage expansion.
Okay, great, thanks, Eric. I'm gonna come back to you with this one. Can you tell us about an unexpected challenge that you've encountered when trying to deploy NVMe in the enterprise space?
It's still early days for NVMe over Fabrics in the enterprise. I think the biggest challenge for me has been, I sort of come at this with a bias, fiber channel sort of background. I think of storage networks in terms of SAN A, SAN B. And so for that redundant connectivity to make sure that you don't lose connectivity to your storage. And it's a really good idea for a number of reasons. But as we've been rolling out this plan to our customers to get them to adopt NVMe, specifically NVMe over TCP, it's been really interesting to find that their ideas about how they should do networking for storage doesn't really match that SAN A, SAN B mentality. They're much more along the lines of let's do one big leaf spine and create dedicated VLANs for storage, and then get your SAN A, SAN B that way. And as we've got a lot of history with storage networking, iSCSI, fiber channel over Ethernet, and so on. And we know that there are going to be problems with that, but it's been surprisingly difficult to get enterprise networking teams to think about the application challenges to storage and what that's going to mean from a leaf spine sort of perspective. So I'd say having to adapt our plans to take into consideration that converged is probably going to be the way that most people go, converged LAN and SAN on a single network. I'd say that's been my biggest challenge.
Before I Curtis, what's your perspective?
Yeah, so there's a couple of different areas that I think of. One of the ones that I think was maybe not really surprising, but was at the same time kind of surprising, was especially in the enterprise server space, the difficulty of explaining and covering the scaling aspects of NVMe have really been interesting. We got used to the storage model where you had storage HBAs and then you put storage behind the HBA. And if you had a 6 gigabit SAS HBA, for example, that had 4 channels on it, you could have 24 gigabits of possible throughput. And your math was fairly simple and your explanation to the customers was fairly simple. You got 24 gigabits of capability there. You got 6 gig capability on this SAS link. That's all you're going to get. And you might get really close to that. When we go to PCIe, we're connecting directly to PCIe lanes to the processor. And the effects of the overall system are way more important in determining your scaling. You can't take a processor that has, making up a number, 48 lanes of PCIe and hook all 48 lanes to NVMe drives and just multiply the performance of your drives and achieve that, because there's other limitations in your system that it can't run all those 48 lanes of PCIe through the memory, through the processor subsystem at full performance. And so how to explain to the customers exactly what their achievable performance will be is interestingly a lot more complex. There's a lot more performance available, but where exactly do you hit that peak? And it ends up being a lot more system specific. So that was kind of an interesting one. The other one is in the fabric space, like Eric was talking about. We've been working on NVMe over Fabric since probably, I think, 2014. We released the first spec in 2016. So we've got 6 years now on the first spec. And I was not in the core team, but I was involved in the early days of Fibre Channel. And we built out Fibre Channel a lot more slowly than we're building out NVMe Express over Fabrics. We're very rapidly building out NVMe Express over Fabrics using the learnings from Fibre Channel, but doing things more optimized for today's world and for the NVMe architecture. But at the same time, like Eric said, we're in the early days, and we're trying to be careful to not go too fast and to enable the industry at the right pace with the right feature level. So, we have to set the expectations with the customers for here's what we call a happy path. We've fully defined how NVMe Express over Fabric works in this area, and we're in new domains. We're constantly uncovering new things that we're working on to make NVMe Express over Fabrics more robust, faster, easier for the customers to use. But we're all going to be learning for a few years, making this better and better.
Let's move on to the next question. We've got here, what are some technologies that NVMe is pursuing to improve NVMe for the enterprise? Eric, maybe we can start with you this time. So what are some upcoming things that we should be looking forward to?
Yeah. For me and for a couple of people at certainly at Dell and at FMDs, the idea of making authentication easier is huge for us. Right now, if you want to authenticate with NVMe TCP, it's DHH MAC CHAP, and you're basically going and configuring secrets at end devices, and it's a ton of work. And it's so much work that it's proven, at least in Fibre Channel, my experience with Fibre Channel, impractical for customers to actually implement. So, and for a while with Fibre Channel, the belief was that because it's a separate network, it's sort of safe or it's secure. And I don't know how valid that assumption was, but with NVMe TCP, people are certainly much more aware of the security vulnerabilities that you could get into. So we need an easy way to make authentication and secure channels work. And so one of the ideas that's been talked most recently is this concept of an authentication verification entity, which is sort of like a radius server, as an analogy, for NVMe over Fabrics. And we're very close to being finished with that specification. And it's really exciting. So that's an area that I think has a ton of promise, and I'm looking forward to seeing where that goes.
Okay. So one of the areas that I might focus on is that I think that we're doing a lot of work to improve NVM and NVMe over Fabrics off of the happy path. I think I mentioned a while ago that the happy path works really well. When things are working well, NVMe over Fabrics just flies. And when problems occur, there's link breakage in the fabric, there's a server goes down, something happens to your storage system. NVMe Express over Fabrics is pretty robust and will recover, and everything gets up and going again. So what there is today runs just fine. But what happens behind the scenes isn't as clean and pretty as it could be. if a link goes down, it takes a while for the entire system to figure out that the communication has been lost and to make sure that anything that was in flight has been deleted, cleaned up, aborted, reconnect, restart the processing. And we think that it could be done better. So the group is working on finding ways to more rapidly detect when there's problems in the network and be able to do less invasive recovery techniques. There's some ideas about trying to shorten that time to recover. It may only happen to you once in a while, but we want your user experience to be as good as possible when those problems happen. There are also some areas that are in the pipeline for being worked on that look at how things work under extreme loads and whether there's some things that we could do to balance some of the loading out a little bit better if the systems are active.
Okay.
So,
yeah. Cool. So the next area that we want to kind of dig into, what are some of the benefits of enterprise customers making the switch over to NVMe over Fabrics? What should enterprise customers be looking at that will help them determine if what the current technology they're on makes sense to continue with, or if switching to the NVMe over Fabrics model is the right decision for them? Do you want to take that one, Eric?
Sure, I could take it. I think about this in terms of where are you coming from. If you're an existing iSCSI customer and you don't have a tight you're not relying heavily on the SCSI protocol, considering NVMe TCP is probably a really sort of light lift for you in terms of switching transports. A lot of the concepts are similar. You don't even have to get into centralized discovery. If you're comfortable with iSCSI's provisioning process, you could just use what you pretty much are doing today and avoid the whole concept of a centralized discovery controller. Although, if you were to use a centralized discovery controller, you'd probably get a better user experience. NVMe also does some really interesting things, NVMe over Fabrics, specifically something that we were discussing yesterday, MDNS, as we defined it in TP 8009. Enables you to automatically discover discovery controllers in the same subnet. So that's another reason why NVMe TCP might be a better user experience for iSCSI customers. My fiber channel customers, if they're adding capacity to an existing environment, you look at fiber channel, and there's really no reason to look at anything else at this point. But if you're thinking about if you're thinking about making a change, or you're rolling out a new application, or you've got some sort of mandate, which is actually what we're seeing a lot of. We're seeing a lot of mandates come down from their management to say, thou shalt migrate from fiber channel onto something else for purely cost reasons. Then really it comes down to looking at the different NVMe over Fabrics that are available. And I think either TCP or Rocky could be used. Depends on the size of your configuration, what you're going to use for switching, all those things. But I think, so that would be my recommendation, would be to stick with fiber channel if you're just expanding, and if you're going into a new environment, start looking at the NVMe over Fabrics. And then again, it comes down to use cases. Specifically, if you really want to do software-defined storage, it's going to be over Ethernet. So just keep that in mind. It's so I'll leave it there.
Curtis, did you have anything you wanted to add for that?
I like the way Eric answered that question. We're seeing some of the same things, and what I've seen in the industry is very similar to what Eric's talked about. It's really important that people that are designing these data centers think about where they are, where they need to be, and what the right technology for them is. There is a lot of excitement about NVMe and NVMe over Fabrics. NVMe PCIe has shown very dramatic performance improvements over where we were with SAS. NVMe over Fabrics has a lot of environments where it's shown significant performance improvements over some of our older technologies, especially in the iSCSI case that Eric mentioned. So if you're a customer that's working with iSCSI and it's working well for you, NVMe over Fabrics TCP will probably give you a little bit better performance, and that it could be a fairly seamless migration. If you're the fiber channel customers, think about what you really need in your environment. There is NVMe over Fabrics fiber channel that a lot of companies support, and in some cases that is the right step to get you into NVMe over Fabrics. The big place where I see people seriously thinking about NVMe over Fabrics, and I think it really makes a lot of sense for them, is when they're working in an environment that is designing a new high-performance Ethernet-only configuration. If you're going into a new high-performance Ethernet environment, you may want some iSCSI for the time being, but you'll be better off with NVMe over Fabrics TCP in the long run.
Okay. Well, we've got one final question here for you guys. How is NVMe able to address the capacity storage needs of data lakes and other enterprise usages that require large amounts of data? Essentially, how does NVMe deal with scaling from a capacity standpoint? Curtis, let's start with you this time.
Okay. So the capacity and the data lake questions is somewhat separated from the NVMe question and relates a little bit more to the media technologies behind it. But the media technologies behind it with NVMe over Fabrics in a number of our environments become abstracted away. And so that's really kind of where we're able to most easily address the capacity space right now. In our environments where we have abstracted back-end storage, our storage systems can provide pools of ultra-high performance flash over our NVMe over Fabrics interface for the performance use cases. But we can put capacity drives in the system as well with whatever the right capacity technology happens to be at the time. And we're seeing a lot of talk today that hard disk drives are still a cheap and deep capacity option. There's starting to be a little bit of talk about NVMe HDDs. Today we don't have NVMe HDDs, but in a storage system providing NVMe over Fabrics front end, frequently you can add a HDD layer. There's also people that I'm sure you've seen in previous years, QLC, quad level cells. There's talk in research papers and various places about penta-level cells, 5 bits per cell, ultra high capacity SSD media that can easily be dropped into an NVMe interface.
Okay. I won't add anything about the different media types that Curtis was speaking to. For me, when I start thinking about large scale applications, I start thinking about how do you manage it, and I put my SAN hat on and I come at it from that perspective. I know that I'm going to have to worry about workload distribution. I know that I'm going to have to worry about so placement, utilization, and so I think as we're thinking about those sorts of problems in large environments, we come at it from, there's an array-based perspective, which array do you deploy on? But as software-defined storage becomes more and more important, it becomes more about where are you accessing that volume and being able to migrate that volume. And that's the reason I was asking you this question earlier, to where it's closest to where the consumer is or at least the presentation of that volume is close to where the consumer is a big consideration for us, to be able to preserve the bandwidth of the environment and also to give the best possible latency. So dynamically moving volumes, presenting them from different storage interfaces is is a big concern for us. And so things like one of the things that we put into TP 8010, the Centralized Discovery definition, technical proposal, was subsystem-driven zoning, which is this idea that a subsystem can indicate to a centralized controller network to the centralized discovery controller where how the zoning should be set up for the configuration. So, like the subsystem will say, I have these 8 interfaces. I'm going to present the storage for this host on these 8 interfaces now, and then maybe later the subsystem figures out this isn't the optimal placement. I'm going to move them to another set of 8 interfaces. The subsystem can make that change on its own. It's notifying the centralized discovery controller that I have a new zoning configuration that you should set up and configure and activate, and then the host is automatically notified, and that can those connections can be transitioned over to the new interfaces. That's really important at scale as you start thinking about software-defined storage. The ability to do that, and it's an area where we're going. I don't think it's not necessarily specific to a data lake, but it definitely is for large-scale systems, and is an area we're really excited about.
Okay. Well, thank you guys for joining us for this talk on the testing and enterprise infrastructure. And please join us for the next hour when we talk more about NVMe topics. Thanks a lot.